Crone, Senior Project Scientist for Hubble Space Telescope. And Dave, you're going to talk to us a little bit about the two new instruments that are going on to Hubble during this mission.
That's right. We're very excited about the technology that's in these instruments. They'll be much more powerful and more sensitive than anything we've had on Hubble before. Specifically, we have a new camera. It's called Wide Field Camera number 3 because it's the third in the line of a particular heritage of camera designs. And like any camera, even your home camera, digital camera, you use a camera because you want to know what things look like. So we take pictures of the universe with these cameras so that we can see the shape of objects, how large they are, get some idea of how far away they are, what their colors are, how bright things are, whether it's stars or galaxies or planets in our own solar system. But this is a particularly sophisticated camera that for the first time will give Hubble great vision both at ultraviolet wavelengths where we don't get ultraviolet rays to the ground because if we did we'd all have skin cancer, and in visible light and in near-infrared light. So we call this a panchromatic camera because it covers such a wide range of colors. And it in particular is going to really help us put together the life story of galaxies and how they form from their infancy way back just after the Big Bang all the way forward to our own time and with nearby galaxies and even our own Milky Way galaxy. And the fundamental question is where did we come from? And our camera will help us deduce that. Okay. And then we have the Cosmic Origin Spectrograph. Got to explain what a spectrograph is. It's the workhorse instrument. It's the most important tool in the hands of astrophysicists. An astrophysicist is a person who tries to figure out what things are made of, how hot they are, how dense they are, how fast they're moving back and forth, or how fast they're rotating. So it doesn't take pretty pictures. So these spectrographs are not glamorous, but the scientists really need them to get quantitative information about the cosmos. And in particular, the Cosmic Origin Spectrograph is the most sensitive, I'd say, ultraviolet spectrograph we've ever put on board Hubble. It can't observe visible rays, but it observes in the ultraviolet. There's a tremendous amount of information there about the content and the temperature and the density and physical properties of things out in the universe. Now, in particular, the Cosmic Origin Spectrograph has one job it really wants to do badly. It wants to look way out across space at very bright objects that we call quasi-stellar sources. They're interesting in their own right, but mainly they're great flashlights. They're extremely bright sources of light. And they send a beam of light in our direction, and it passes through the material that's between us and that quasi-stellar source. And that beam intercepts gas between us and the quasar, and some of the light from the beam gets absorbed out by the chemicals in the gas. So it allows us to tell what the gas is made of and how hot it is and so forth. This is very important because that's the gas from which galaxies form. So if we want to understand the process by which galaxies form physically, we need to actually get quantitative measurements of the stuff that's going into making new galaxies.
Now, I understand, earlier we talked to one of the project people, and we found out that there's going to be repairs for two of the already existing instruments, and that those are going to complement these. How does that happen?
Well, one of the two instruments is the Advanced Camera for Surveys, and it's a very powerful camera as well. Has somewhat similar light sensors as Wide Field Camera 3. And because the two, we hope, will be able to work in tandem, we consciously designed Wide Field Camera 3 to complement Advanced Camera for Surveys. In particular, Advanced Camera for Surveys is great in visible light, the light you can see with your eye, and maybe just a little redward of that. And because it's so great in those colors, we've designed this camera to be really great in the ultraviolet and in the near-infrared. So great coverage all the way from the ultraviolet through the visible, the red, and the infrared with these two cameras together. And Cosmic Origin Spectrograph similarly has capabilities that the repaired spectrograph does not have, and vice versa.
Okay.
Yeah.
Great. Well, it will be exciting to see what kind of imagery comes out of these instruments.
Right.
Dave, thank you so much
You're
for your
welcome.
time
You're
and
welcome.
Enlightening us on the new instruments. And George, we'll head back to you to have an update on the countdown. Thank you.
Shuttle launch control, 15 minutes, 55 seconds remaining. Shuttle launch director Mike Leinbach is being briefed by the ICE inspection team right now.